Alright, so we are on 5-4, solving radical equations, and this is just applying all of those rules that you know about, and so let's go. So, I want you to look at these just like, if this was 9x equals 36, how would you solve that? So you would first divide 9 out of both sides. So you're going to do the same thing right here. So that 9 and 9 cancel. I get the cube root of x over 4 equals 4. Now, how am I going to undo a cube root? I'm going to cube that, because now we understand that this is the same thing as x over 4, to the third, and if I take that to the 1/3 power, I'm cubing that. Those two will cancel each other out. So those cancel, and so now I just have x over 4 equals 64. To solve that, I need to multiply both sides by 4. So I get x equals 242.56. I can go back in and check that. 256 divided by 4 is 64. The cube root of 64 is 4 times 9 is 36. So that checks out. Okay, down to number 4. You've got 2 cube roots set up here. But what I can actually do is move one of those to the other side. So I'm going to move the second one, because then I've got a positive going on. 26 minus v. That's gone from that side. Now that I have cube root of v minus 8 equals the cube root of 26 minus v, I can actually cube both sides, which will cancel out my cube roots. And I have v minus 8 equals 26 minus v. I'm going to add v to that side and add 8 to that side, so I get 2v equals 34, so v equals 17. Alright, let's go down to number 7. So in order to undo that square root, I actually need to square both sides. So I'm going to square that side and square that side. So when I square a square root, I get rid of that root altogether. So I have 6 minus a equals a squared. In order to solve for a quadratic, I need to set that equal to 0. So I'm going to move, since my a squared is already positive, I'm going to leave it that way. So I'm going to move these to the other side. I'm going to do that by doing the opposite. So add a and subtract 6. And if I want to flip that around just to make it a little bit more aesthetic, I'll set that on the left side and set it equal to 0. And now all I have to do is factor. So I need two numbers that multiply to -6 that add up to 1. This is like a 1 in the middle. So that would be +3 and -2. Then I need to solve for each of those, which is the opposite of my factors. So a equals -3 and a equals 2. Okay. You do need to check to see if any of these are going to give you an appropriate answer. But if a equals -3, that's 6 minus -3, which is 9. Square root of 9 is 3. And if I take the square root of both of these sides, I have positive and negative, so that works. 6 minus 2 is 4, and the square root of 4 is 2, which is also my a value, so those both check out. Alright, let's flip it over and do one more. So we're going to do number 10. So again, I need to get rid of that square root, so I'm going to square both sides. Be very careful when you're doing this. These two just cancel out. So on the right hand side you have 7p minus 26. Over here, be very careful that you include your middle term, because a lot of you are dropping that. So -2 times -2 is +4. P times p is p squared, but I have a middle term in there. One way you can do this, if you don't do FOIL, here's kind of another method. Multiply your diagonals. So -2 times p is -2p. -2 times p is -2p. So my middle term should be -4p. So on this side I have p squared minus 4p plus 4. I need to get this quadratic set equal to 0. And I'm going to move these over. So I need to subtract 7p and add 26. So I'm going to get p squared minus 11p plus 30 equals 0. Now I'm going to factor that, so I get p minus 6, p minus 5 equals 0. So my solutions are p equals 6 and p equals 5. Okay, and that's it. We'll do the rest of them in class. Thanks.